So this is Felipe Figueiredo from Caxias do Sul, Brazil. I was invited by Dr. Fernando Gomes Sancha to present a lecture about the evolution of instrumentation in the endoscopic enucleation of the prostate. MiLEP, minimally invasive laser enucleation of the prostate. I have dedicated the last few years of my career to BPH treatment, and all my patients are treated with this new concept that is the miniaturization of the endoscopes to perform HoLEP. I work in Pompeia Hospital in the Enlarged Prostate Institute in Brazil. And I would like to thank Dr. Fernando for his efforts for the widespread adoption of HoLEP worldwide. I believe this YouTube channel is one of the most complete video source for those who want to learn the technique, with many tips and tricks and dozens of surgeries. And Fernando had played this major role in the adoption of the HoLEP worldwide that we have seen in the last 5 years, and I'm really happy with this invitation. My disclosures: I have assisted in the development of these smaller scopes by RZ Medicine Technique, which is a German manufacturer, and I run HoLEP courses in my hospital for Quanta System. So the most successful endoscope that we have seen is the Iglesias resectoscope from 1975. It's continuous flow, so before that you had to stop your resection to empty the bladder every few seconds, and it's rotatable, so you can rotate the working element without rotating the outer sheath, and is widely adopted worldwide. But originally the endoscopes in 1938 were originally made in two sizes, 28 French and 33 French, and it was abandoned because of the amount of urethral trauma and stricture. Many patients had to do a perineal urethrotomy to be able to pass it, and Nesbitt was the first to propose a reduction in the caliber of the endoscopes to reduce urethral trauma. So he proposed to reduce from 28 to 26 and 24 depending on the size of the prostate. So we have a smaller sheath and a smaller loop to treat smaller glands. But it was intermittent flow and non-rotatable. Then Iglesias proposed to add a second layer, another sheath outside, and this would allow, with this extra sheath, to a continuous flow, and you don't need to stop your resection to empty the bladder. And he also proposed two sizes, 28 French and 25 French for smaller glands. And then this new concept of continuous flow is the possibility to have the irrigation through the lumen of the inner sheath, and in the outer sheath there was small holes that would allow the fluid to go between the sheets and go out in the second stopcock. And the initial paper described to add suction to the outflow, so you could reduce the pressure inside of the bladder, and that way reduce the absorption of the irrigation with monopolar that could cause hyponatremia. The modern sheets are available also in this single sheath with a 24 French sheath and loop and 27 French for larger slices. And the continuous flow is the most adopted, is available with 26 French sheath but using a 24 French loop in the inner sheath, and 28 French outer sheath and 27 French loop, which is not popular in Brazil and Europe, but in some parts of the world, like in the US, they still use a lot the 28 French sheath, both for TURP and for HoLEP. And this difference of the fixed inner sheath is that when you rotate the working element, you have to rotate everything. So you have this rotation of friction in the urethra. And this new concept of the rotatable allow you to rotate the working element, and the outer sheath is fixed, so you don't have this this friction in the urethra and reduce the urethral trauma. Peter Gilling in 1998 was the first to describe HoLEP, but he used the same 26 French sheet from TURP. But with the laser you don't have the loop and you may burn the ceramic tip. So this is one of the problems. You may touch the ceramic tip with the laser and break it. And he proposed not to use the working element, but a laser bridge and a catheter. So this bridge is different from the cystoscopy bridge because it's longer, it fits the resectoscope. And then in the tip you had a metallic tip with a ring that would stabilize a catheter, a laser catheter. This is still used in some countries that were pioneered after Peter Gilling, like in the US and in UK, in London. But it's only available with a fixed inner sheath. It's from car stores. The evolution of the system is the possibility to have a bridge with a laser channel, so you don't need a catheter anymore. And later on we had the Kuntz laser working element that would have the same handling of the standard working element but with the laser channel, and this allows you to adjust the working distance of the fiber. This is very popular in Europe and this is my favorite too, but some doctors like Fernando still likes the bridge and the channel because you have less instruments that allow you to rotate without hitting the legs. But this is personal preference and both work very well. But these two systems allow you to work with the ceramic tip without burning it because it stabilizes the fibers very well. And then we had this new concept of the blunt enucleation that Fernando proposed with the MiLEP and later on Thomas Hermann with TULEP. And we use the ceramic, the tip of the resectoscope as the finger in open prostatectomy. And if you have a larger metallic tip, it reduces the risk of perforating with these blunt movements. And Richard Wolf has this blunt metallic tip for MiLEP and even for HoLEP. But I want to show you a real life case. When I was starting in 2017, I started in 2015, and this was a young male, 58-year-old with a 60-gram prostate, and I was starting my HoLEP, but he had a very tight membranous urethra. I tried to negotiate, but it was difficult. I didn't want to create trauma, so I stepped back. And what should we do in such cases that happen really frequently? So in this case, one option is to adjust the urethra to the instrument. So we can have these metallic dilators. In Brazil we call it Beniquet, in the US Van Burreshoud's. And with this dilation we create this circumferential trauma that can create a circumferential scar. And after the metallic dilation, you can see there was some degree of trauma, especially in the membranous urethra, and it was still tight even after the dilation. But I could eventually go through it and do the procedure, and it was an uneventful procedure, no bleeding, perfect fossa. The second problem is that we have these elevated steps in the outer sheath between the obturator and the inner sheath and the inner sheath and the outer sheath. This step creates a lot of trauma in the meatus and in the membranous urethra. And the last problem is the grater effect. We have this concept that the holes in the outer sheath can create friction like a vegetable grater. And sometimes at the end of your procedure you have a very damaged urethra and sphincter. And then after 2 or 3 months you have the perfect fossa, but you have a stricture. And this is extremely frustrating for the patient and also for the doctor. He came for a minimally invasive endoscopic procedure, and this patient had to do an open urethroplasty to fix the stricture. And this is very frustrating. The incidence is not so high, but every case like this probably can be prevented if we change our mindset. And if we check in the literature, we can see that the stricture rate is not so low. This recent paper from 2 centers in the US and Egypt, with 100 patients in each group of TURP and HoLEP using 26 French sheath, they reported almost 8% stricture rates in the TURP arm and almost 5% in the HoLEP group. So this is not low in my perspective. So the second option is to adjust the instrument to the urethra. With HoLEP, we have a very small fiber, it's 550 micron. And we don't need to use the 26 French sheath to do the enucleation. We have the 24 French sheath available from Richard Wolf, and now we have a 22 French and 18.5 French sheath. And this is the idea. You have a 22 French resectoscope that is 22 continuous flow and rotatable. So you can reduce the trauma by the rotational movements, and it needs a special 2.9 millimeter scope. Originally, this was an hysteroscope for hysteroscopy by the gynecologists. They reduced the size, but you can treat any size of prostate with this instrument. A few days ago, I treated my larger prostate, so far 400 grams. In the MRI, it was 332, but the specimen weight, calculating the morcellated weight reduction and the peripheral zone, it was estimated in 400 grams, and with perfect vision. Another modification is that I needed to reduce the steps, so I propose a new obturator. It's a blunt and bigger, so you have only one step between the obturator and the outer sheath, and I asked them to create very small holes, more holes but smaller holes, to reduce the friction with the greater effect. And the gynecologist also had the 18.5 French ultra slim resectoscope. Then I tried, and it works too. So in smaller glands below 80 grams, I use the 18 French resectoscope in all my cases. This is more than 50% of my cases. And in bigger than 80 grams, I use the 22 French sheath. So this is the comparison. It's too big, 26 too big, maybe not for all urethras. If a patient has a catheter for many weeks, the urethra is dilated, 26 probably is okay. But in 30% of the cases, 26 is too large. 22 is a great combination of excellent irrigation, perfect vision, and you can treat any size of gland. But in my practice, this is too large in some cases. And now we have the 18.5 French sheath that allow you to do the enucleation of any gland too, but the vision is not so perfect. The irrigation is not so perfect like the 22. So I decided to use only for smaller glands. So we published this paper and video in Urology Video Journal describing this new concept of minimally invasive laser enucleation of the prostate with the slim HoLEP 22 French and the ultra slim HoLEP 18.5 French. So I want to share another live case from last year, March 24. It was a large gland, 130 grams, in a 67-year-old male. And when I was introducing the 22 French sheath, the bulbar urethra was really small. And this patient came from another state, from São Paulo. His urologist came together, and I said, okay, this is a large gland. The ideal endoscope would be 22, but I think it's too long to be working with high friction, and I didn't want to dilate. So what I did was to downsize the resectoscope for the 18 French Charrier to perform the enucleation. And then after changing, you can see that the 18.5 French could pass through the narrow part of the bulbar urethra without trauma. This for me was a game changer. Now we have options. Not all patients fit the large instruments, and you can adjust your instrument to the urethra of the patient. Maybe not for all patients like I do, but probably you see in your practice small urethras like this. But how can we morcellate? So the standard morcellation proposed by Peter Gilly was to have an adapter, a bridge, that could fit the long nephroscope from PCNL in the outer sheath of the 26 French resectoscope. But then we proposed a slim Morcescope. I said, okay, we need to downsize the optical system to be able to fit a 5mm working channel that could fit all morcellator blades and to have a good irrigation. And this was the project. I'm very thankful and grateful for RZ for believing in this concept and in this idea. And this is the Morcescope. So it's not so new, since 2021, so I'm using for 4 years. You don't need any adapter. It was not for PCNL. You can just remove the inner sheath and introduce it in the same outer sheath of the 22 French system. And they even put a logo with my name in it. So the Morcescope, the idea is to have a very small optical system. It's fiber optic, so we compromise the quality of the vision. It's like an urethroplasty, but it has good vision, good lights, and 2 large irrigation channels. And we have a 5mm working channel that works with any morcellator in the market. And for me, the irrigation is the most important part of the Morcescope. And this Morcescope has an excellent irrigation. But is smaller better? Do we have evidence that this could provide some benefit? We have a couple papers, but this is the best one from my friend Mario Sofra in Tel Aviv. And he compared 26 with 22 HoLEP. And the operating time was the same. He had to do some metal dilation in 70% of the 26 French group, but only 23% in the 22 French group. So here we see that some patients still have tight ureters even for the 22. The efficiency was similar, so MiLEP was 0.94 grams per minute and HoLEP 0.8, not statistically significant. But MiLEP was slightly superior. The hospital stay was the same, the complication was the same. The incontinence rate in the post-operative period was very different. The definition of incontinence here was any drop of urine in the underwear. So it was a very strict definition. In the MiLEP group, in the first month, he saw 15%, and in the HoLEP group, 40%. This is high, but it has to do with definition, okay? And we see a 62.5% reduction in the incontinence rate with the same technique, the same surgeons, but only reducing the size of the scope. In 3 months, it was 0 in the MiLEP group and 3% in the HoLEP group. What about strictures? It was not a very large group, so they had only 1 metal stricture in the 26 French group, but MiLEP was also superior. And then we now have this new project, is the high flow enucleoscope. The idea is to improve the irrigation and the visualization in the apical part of the procedure. Why? Because this is the first purpose-built enucleoscope. Before that, we were working with resectoscope for TURP, and this was designed for enucleation. Okay. So if we remember the Iglesias, this is slide from the Iglesias concept, the inflow comes through the inner part of the inner sheath and comes through the holes, the small holes in the outer sheath. And between the sheets there is a small space that the irrigation comes through the outflow stopcock. So if we check the shape of the inner sheath, it is larger at the tip, and this long ceramic tip obstruct the first 4 lines of holes of the outflow. So for TURP it's not a problem, but for enucleation, when we are working at the apex and especially doing the early apical release at the mucosa, sometimes we have a very vascular mucosa, you have a very poor outflow because the holes are blocked inside of the membranous urethra. So the Iglesias resectoscope was not designed for enucleation, especially the en-bloc enucleation that Fernando, me and Scufoni and many others use for the technique. So we propose this new design. It has a short metallic tip, and then we have these grooves at the metallic tip that allow the outflow not only through the holes in the outer sheet, but also from the front, between the sheets. So we improved the outflow in the first 4 lines of holes, and this new concept of the grooves allow the front outflow. And we did this in vitro evaluation with a pressure pump using 60 millimeters of mercury, which is equivalent of 81 centimeters of water, using a glove finger as the bladder, comparing 26, 22 and 18 French using the ceramic tip and the new metallic tip high flow system. And this is the lab test. We use a barista flow meter to check in 1 minute how much fluid would we have through the outflow and consequently through the inflow using this concept. And then we close the holes using a tape to check how was the outflow with the ceramic tip and the metallic tip 22, 26. So when we close the holes, we only have front entrance of fluid. And what was the results? With the 22 French high flow with all holes open, compared with the 26 with the ceramic tip, we had similar outflow, 250 milliliters per minute and 283 millimeters per minute with the ceramic tip 26. So 26 is a little superior if we have all holes allowing the outflow. But this is not what happens in real life, because when we are working, the holes are blocked in most of the part, especially at the apex. So we did a comparison of this new high flow system, 22 French, with the 22 French ceramic tip blocking the holes. And the results were surprising, because the new system, if we close the outflow from the holes only from the front entrance, still allowed 145 milliliters per minute and only 17 millimeters per minute with the ceramic tip. So we increased more than 8 times the flow. And then we did this comparison, 22 French high flow system with its 26 French ceramic tip blocking the holes. And this is real life, okay? We are releasing the apex, the sphincter, and even with the ceramic tip, we still have less flow with the 26 French sheath than with the 22 French. We have 41% more flow with this new design. And I think this would be a game changer for the enucleators around the world. Currently is only available with the 22 French, but we are working also for this new concept with the 18 French sheath. And I work in Brazil in the Enlarged Prostate Institute. I'm part of one of the centers of Quanta Training Lab to learn the HoLEP technique in Latin America. I'm one of the 3 centers, like Fernando in Spain, and I also do these trainings for RZ medicine technique. These are my contacts, my email, my Twitter account. I also have a YouTube channel, but I don't upload a lot of videos like Fernando, so Fernando's channel is the most complete source of knowledge. But it would be a pleasure to have some of you here if you want to see by yourselves this new concept. Thank you again, Fernando, for the opportunity, and bye bye.